Hello and welcome to SGN Tech Forum. How are you guys? So today this is the final installment of our small home office network design, and I must confess I am also pleasantly surprised with the outcome. Right. So we started with a small vision of adopting ASA 5500, which you can buy on like on eBay and other places, and then we started plugging in a small component which I already have in my network, and final outcome is like really nice. So right now we have an ASA which is interfacing the inside and outside to the internet, and then we have a snort plugin which actually spans all the traffic in both ways on WAN interface of my ASA and locks or matches it against the snort rule, right? And then we have DSCP server hosted on ASA 5500. And since ASA 5500 DSCP capabilities are primitive, that mean you cannot do much of the fancy stuff because it was never meant to be a DSCP server, right? So I'm doing some kind of like workaround to do some static mapping between layer 2 and layer 3, and I'll show you that in a video. And then, as you can see, ASA, SNART, and these switches, they generate tons of logs in form of like ASA logs, SNART matching rules, and here you can have NBAR and SNMP. So eh, all those data, I mean, they were like distributed, right? So that arise a need of having a SIEM, security and event management sort of things. So we ended up deploying Splunk, which all my Splunk forwarder on these devices, they actually send it to the Splunk controller, and then we can do visualization and reporting. So I'm sure if you follow my last 2 3 videos, which I'm going to combine as a playlist, you can also go ahead and build this network for yourself. All right. And we also have the NAS storage here so that we can do some port forwarding here and access my NAS storage securely when on the go. Right. And in this final part, what we are going to talk about, we are going to talk about having a need of a secure DNS server. Right. DNS server, you get it from your ISP, or you can use Cloudflare and Google anything, right? But having a secure DNS server is also a key component of security nowadays, right? So if you're getting a malicious link, Cloudflare and other, they may not be able to block that based on their reputation or something, right? So here comes my secure DNS server, which I have the complete visibility and control. That means I can see where my networks are going, and it has already dynamic blacklist, which getting updated very frequently. So all the malicious links, even if you receive on your email or SMS, they will be like blocked. And at the same time, since it is accessible to you and you are actually managing it, you can easily go and update new rules if you want to block any site. And not just for one device. We are going to enforce this DNS security on all the connected devices in our network, whether wired or wireless. And that's what we are going to do in this video. So I'm going to reuse my Pi-hole, all right, and let's go and talk about this secure DNS server. Okay, so a couple of years back, I made this video. I highly recommend you go and watch this. Pi-hole, you can use standalone. You can build on a standalone as well, right? But that's like a little bit time consuming. Balena orchestrators or Balena Hub give you a very nice and quick way to build your Pi-hole, right? You can just download the image and plug it in your network, and you will get a cloud interface, right? And it's free. So highly recommend watching this video, and that's the thing we are going to use in our network. Okay, this is currently my Pi-hole, which is accessible locally by using any LAN interface. All right. So what I'm going to do, I'm going to talk you through how we implemented this Pi-hole. And I must admit, I ran into a couple of problems, and I'm not going to hide that from you. Okay. So you will watch me running into issues and how I worked around it. Okay. So I'm doing this so that if any one of you ran into similar issue, you know what to do, right? So no editing of that video. So if things happen to repeat, please bear with me. Thank you. Let's start. I'm going to speed it up a little bit. So this is my Balena dashboard on cloud. Okay, so you have to have a Balena account, and you just watch my video, follow along, and then you will have your device available in cloud. Okay, so what I want to do, I want to make sure that I can access this locally. So what you have to do, you have to go to device variable and change the setting if you are using your wireless interface. Just DNS mask listening and interface, change it to from ETH0 to WLAN 0. All right. And here you can see you can connect to your host directly from the cloud, okay, but from your Balena account. And as you can see, the IP address is 192.168.1.13. That is our Pi-Hole DNS server IP address. On dashboard also you can see local IP address / MAC addresses. Okay. Other terminal, what you can connect to the Pi-Hole itself, not the DNS server, but the orchestrator layer, right? Because it is shipped as a container. Okay, and this is how you're going to access. You're going to put the IP address, HTTP, and then there are a lot of nice settings there, like tools. You can see um, all Pi-Hole Ethernet interface and all those things. As you can see in the nice dashboard, it says total number of queries and how many clients are using this. So right now you can see only one client is using this DNS server for their DNS query, and that is the local host. That is the Pi-Hole server itself. That means my other devices, they are not using this DNS server. So let's validate that in Mac, and I think I'm going to slow down a little bit, okay, and talk about these commands. As you can see on Mac, if you're on Mac, you can check what name server you are using for your DNS queries, and that is with scutil command. So I'm saying scutil -- DNS, show me my name server. I'm going to give you this from on my GitHub's repo. So you can always copy and paste this command. And as you can see, I'm getting a 209.18 DNS server, which comes from my ISP, right? So right now, today, I do not have any control. It just comes dynamically from my ISP. And if I try to connect, it just query to that server. Now let's go ahead and log into our firewall and try to configure a DNS server of our choice, which is Pi-Hole. Okay. So this is our ASA 5500, which you have like seen how we built it in earlier video. Show run, include ARP. As I mentioned, we cannot do the DSCP reservation. So I performed a workaround, and I did a ARP mapping of layer 3 to layer 2, so that every time this Pi-Hole comes in the network, ASA allow the same IP address or allocate the same IP address to this. That's where we can make sure that the IP addresses are static in nature, because you do not want your DNS IP server to be changed very frequently, right? So let's try to do something where we can make it static. And then now let's go ahead and configure the DNS server for our LAN environment. So what I'm going to say, DHCPD DNS server IP address, which is Pi-Hole, and it is sitting on interface inside. So all my inside interfaces, they are going to use this DNS server. But as you can see, I got a warning, right, or error. Address overlap with DHCP pool IP address. Okay, since my ASA is using or my ASA is a DHCP server for my inside network, and Pi-Hole, when it came up, it also got the IP address on WLAN 0 by ASA from the same pool, right? So as you have seen, that kind of like conflict is not allowed. DNS itself cannot get IP address from DHCP pool. So what we infer? We infer that we need to separate the DHCP pool and IP address of DNS. So somehow we have to assign a static IP to my DNS server, which is outside the scope of DHCP server. So I hope you are following along with me. So what is the problem here? Problem is my Pi-Hole, when I downloaded the image, it was using DSCP. The configuration was, the network configuration was to use DSCP. All right. So we are going to change that behavior, and how you can change that behavior. This is the Balena post which I am highlighting. So basically, what we are going to do, we are going to create a new network connection and assign a static IP address. Okay. And for that, what you have to do, you have to again go to Balena cloud and go to the right folder. Okay. CD etc network management system connection. Within system connection, I created a new file which is Raisin Ethernet, and make sure that you set the permission chmod to 600. Okay. Uh, and now this is the same thing what I shown you as a blog. So we created a new interface called Ethernet, and address is 192.168.111/24. That is my DNS server, and then the gateway, which is ASA. Okay, so we created the file, and now what you have to do, you have to reload the network manager. Okay, so you can do that. And NMCLI is supported. So I'm validating that using NMCLI. You can see NMCLI, my Ethernet is up. Now I'm not using WLAN. This time I'm using my wired interface and trying to assign a IP address, static IP address to that. Okay. Uh, Okay, there are a lot of interfaces, Docker and other things. Right now, you can see my ETH0. It has got the IP address because I created that static configuration and reload the network manager. When you reload the network manager, you can watch using journal CTL and make sure that if there is any error or something, you will get there. But if all your file syntax is good, your Balena Pi-Hole will get a static IP address. Now, I'm going to reload or refresh my browser with new IP address 192.168.111. Again, I do not have the password. So for password, what you have to do, you can remove the password or reset the password by going to Balena Hub. Now this time connect to Pi-Hole services, not the host OS, Pi-Hole services. And as you are connecting to Pi-Hole services, you need to do this command. Okay, and the command is listed on your web interface itself, sudo pi-hole -a-b. Okay, so you are essentially asking to reset the password. Okay, enter a new password, blank for no password. I'll keep it simple, blank. I don't want to set any password right now, so just say login, and here you go. You are again inside the interface. Okay, and same thing. Right now, only one client is listening to using this DNS, and that's the Pi-hole itself. Now let's go back to ASA and try to fix the issue what we encountered before, right? So now this time we will configure DHCP DNS with new IP address, and let's see if that is okay. Okay, because this time the IP address is beyond the DHCP scope. Perfect. No error. Awesome. That means now my ASA know that on inside interface, this is the DNS server I should send to all the internal or inside client. Let's check what is the behavior on Mac looks today. Okay. So we'll use the same command scutil and see the name server, old name server. Why? Because it's cache, right? So we need to kill the process and flush the cache. And how you can do that? You can do that on Mac using the same scutil. Um, Window also, there is a way to clear the cache. Please Google that. I'm not a very big um, window person. So what you can do, DNS cache util flush and then kill MDNS responders. So that will clear the cache. Do it a couple of times, okay? And you have to do it via sudo. And then let's validate what happened. No, still sticky. So you have to do it like a couple of times. Or the best way, what you can do, like it's a bit intrusive. You can reload your machine. Um, but I'll try to do like a soft flush and see if that helps. All right, we have done it a couple of times. Now let's check. No, still the same. Okay. Again, as I mentioned, I'm not hiding anything here, right? So flush DNS is not working for me. What I'm doing sidewise, I open my system preferences and I am flapping the interface. So I'll take down the WLAN or I can simply turn off my Wi-Fi and turn it back again. Okay. And let's see if that helps. I don't know, it may be a combination, but I tried both things. And let's see. The ultimate goal is to get the new DNS server as my name server, right? So that's what I'm doing in another screen, basically just going to Mac system preferences, look for the network and turn off the, uh, turn on your Wi-Fi. Or you can do it from, yes, here you go. 192.168.1.111. That's my name server 0, preferred name server. And that's what we wanted, right? So all my endpoint, wireless endpoint, they started getting the DNS name server of my Pi-hole. And let's see what happened when you try to connect to a website or something. So which name server is helping you with that? As you can see, server query time is 55 millisecond, which is a little bit more, obviously, because there is no cache build, but server is our Pi-hole DNS. All right, now let's watch this the same thing from the web interface of Pi-hole. I'm going to reload it, and as you can see, I'm not concerned about number of queries, but number of total client started increasing. 192.168, 1.26, that's my Mac, and you can see it is using Pi-hole for its DNS queries. And now we'll spend a couple of minutes understanding the Pi-hole web dashboard and see you can see all new clients are started appearing also. So the number of client will keep on increasing as they come online or refresh their network. Okay. So you can see total number of queries, nice charts like what is blocked, what is cache, and all those things. How many IPv4, IPv6, and all those things. Traffic. So you get awesome visibility, right? Long-term data, query log, top list. You can see like what are my top domains, and you can select date and time range that okay, show me last 30 minutes, 1 month, and all those things. So my top domain allowed, top domains blocked, everything will be shown here. Top client, who are my top clients? So uh, very nice and granular visibility into my like DNS activities, right? So this is a web interface, and it basically Pi-hole typically keep on sending heartbeat to make sure that it's saying that okay, I'm alive. And here you can get a nice graphical of like what is your CPU uses look like, what is the temperature of that Pi-hole sitting in the rack, and how much memory utilization and all. I'm using a bit of like an old Pi, which is Pi 3, and hence my CPU utilization is spiked, right? Because I have more than like 30 devices in my network. I'll let you know how it goes, but probably it's a good idea to use Pi 4 instead of Pi 3 because it can give you more resources in terms of like CPU. Uh, Keep a backup, so you can always have a Pi-hole configuration backup, so that when you try to build with a new Pi, you can simply do a backup and restore. You do not have to go through like everything again. Okay. Pi-hole can serve as a DSCP server itself. So instead of my ASA working as a DSCP, probably I can use this one also. But again, this is a Raspberry Pi, and I do not want to put that much load at this moment. Tools are like very important. Here are a couple of things you can see. You can do Pi-hole diagnostic, health check, and all those things. Query list. You can run your query just like any matching string, any domain you want to see if I'm going to that domain and all. You can run the query on demand. Tail, Pi log, Pi-hole logs. This is a real-time log. and you can see all your network DNS activity. They will be displayed here in real time. Very, very useful data, right? I wish they had any third party kind of integration, just like what we are doing with ASA and Snort. I wish I can send this log to some cloud or any other SIEM. Now, the network setting, you can see they are color coded. So they will show you in light green which endpoints are using my Pi-hole, and this orange one is basically which one is not using, and the one which is not using is basically the internal Pi IP addresses, because there are some Docker component and all those things. So which is expected. I want all my endpoint to be secure. Okay. Number of client keep on increasing. Top permitted client dashboard visit, you can definitely change as per your will. You can move around things and keep what you want on top and all those things. So you have secured your DNS, you have defense in depth, you have ASA, you have Snort, uh, control over your DHCP IP addresses, and everything about your network you can visualize on Splunk dashboard slash PRTG bandwidth monitoring, which works on SNMP, and all of these you did with without much investment here. So I hope you can also follow along, and this entire video series proved to be useful for you. And if you follow and build a small home office network for you, please do let me know in my in comment, or maybe you can send me a direct email at sdntechforum@gmail.com. So thank you very much for watching, folks, and keep on building networks. Thank you.